Hey, what up, and how is it going? Today, we're going to do a little kind of algorithm corner. We're going to take you inside and break down an algorithm to reverse a list manually in place in Python. Of course, we have the reverse function. We have ways to reverse using convenience functions, but I think it's good to kind of see how it is done manually to kind of give you those skills. Of course, the convenience functions are always going to be available, but want to kind of show you sort of maybe on the inside how something like a reversal of a list works, doing it in a manual fashion. You're going to need skills like this as you move forward as a programmer. Just the ability to manipulate lists manually in different ways. So I've got the code here on the slide, so let's dive in here. And first, simply creating a list here. And I want to break down generally how it's going to go. How you begin the algorithm is you find the midpoint of a list. And this list has an odd number of elements, so naturally the midpoint is where you have the same amount of stuff before and after. So this is the midpoint. You find that midpoint. It's at 0, 1, 2, 3, index 3. And then how the algorithm works is you're actually going to loop forward until you hit that middle. And you're going to stop right before you hit the middle. So like while whatever variable is less than the midpoint, you're going to go forward. For each iteration, what you're going to do is you're going to take the current element and swap it with the corresponding element on the other end. So element 0 is going to be swapped with the element at the end. So it'll turn into, like after the first pass, it'll turn into 7, 2, 3, 4, 5, 6, 1 after the first pass. And then the second pass, the 2 is going to get swapped with the 6, giving you 7, 6, 3, 4, 5, 2, 1. And after two iterations, you've got the 1 and the 2 swap with the 7 and the 6. So as you move inward, you're going to be swapping. And eventually, it's going to turn into 7, 5, or 7, 6, 5, 4, 3, 2, 1. Yeah, so let's look at the code now. I'm going to set I to 0 because I'm going to use a while loop, so I've got to initialize. I'm going to get my midpoint by getting the length of the list divided by 2 using integer division because I don't want to mess around with decimals, of course. And then, as I was saying, I'm going to loop while I is less than the midpoint. And what happens here on these next 3 lines, this is essentially, or not essentially, it's really a swap. This is a swap of the current element with the element at the other end. And the syntax is just a little complicated, I guess you could say. Well, it looks complicated, not really. Everything's simple, right? And what I'm using is kind of the classic swap algorithm, where you use 3 variables to swap 2 variables, where you have like one variable off to the side as a temp variable to hold the value of one of the variables. Kind of works like this, where you have, let's say you have variables A and B, and you want to swap them. What you'll do is you'll make a temp variable equal to A, then you'll make A equal to B, So they're really, at this point, they have the same value. A will assume the value of B, and then B will assume the value of temp, which was the old value of A. A is B now, and then B is A's old value, so you have a swap there. So this encompasses a swap. And that's exactly what's happening down here in the while loop. And so create a temp variable, make it equal to the current element. You can think of it as like on first turn it's element 0. Then, and yeah, you can think of z of I as A. And then on this next turn, you have z index I equals this conflagration. So let me talk about this. This is a way to generically index the I guess the last elements coming in, where we have z, and we're indexing, getting the length of z minus 1. We know that the length of z minus 1, if we isolate right here, the length of z minus 1 is going to be the last element. The length of z minus 1 is always the last element. And then after that, we minus I, and this is the changing portion, where, of course, I is going to increase as we iterate through our loop. So you will be subtracting an increasing number every time. So, like, let's say the length of z minus 1 is 7 to begin, and then I is 0. Of course, that equals 7. Then on the next turn, I is going to be 1. The length of z minus 1, and actually I think the 7 is wrong, but anyway, let's say the length of z minus 1 is 7. It minus I this time is going to be 1, so it'll be 6. And then next time I is 2, it'll be 5. So you see, this is decreasing, and it allows you to come inward. I know that 7 probably, it isn't accurate in this case, but the idea holds that whatever the length of z minus 1 is, the changing I is going to make it smaller, moving it inward. Absolutely. Yep. So really, this is essentially the line A equals B. That's what it is. And then on this next line, this would be the B equals temp line, where we have our element coming from the end equaling temp, thus completing the swap. And then here, I plus equals 1, we are simply incrementing the iteration variable in the while loop, just going one step further. So that's how you reverse a list manually. And let me also take a minute to run this code, because nothing's good until it runs, right? So I'm going to pop over PyCharm, and we got the code right here. And this is exactly the same. So let's run this, and need a print statement. Gonna print z, and this will sort in, or not sort, it'll reverse in place, where the result is that z is going to equal the reversed list after this. Got tongue-tied there for a minute. All right, so you look at line 3, you got it in this format, and then it's reversed down here. And let me do another one just to ensure there's no smoke and mirrors here, which ought I be doing any sleight of hand up in here. Okay, here's another list, and it'll reverse this one as well. Good. So yeah, this is how you reverse in place. Starting with this, and we get this. There's your result, kiddies. And that's it. This is how you reverse a list manually in place. You can use these skills for further algorithmic programming excellence. That's my time for today. Hope you liked it. I definitely did. And with that, I'm out of here. See y'all later.